So, hey everyone. In this video we are going to be doing absolute value inequalities. So as you can, if you remember from the last video that I recorded, I did linear or absolute value equations. And in this video we're going to be doing absolute value inequalities. So, and this is supposed to say absolute value inequalities. So usually they're of this form. Not all of them are of that form though. There's like this example is not, it is of that form, but it's like, a equals 1, and then m equals 3, b equals 1, and c equals 0, and y equals 9. So usually, it usually is always of this form. This is the most general form. They call this the vertex form. Usually they also write it like this, where HK is the vertex, but we're not going to focus on that right now. We're basically going to do, absolute value inequalities. So I'm not sure if I did a graph or if I did do a video on graphing them, but I'm going to be doing that really soon. For this first problem, what you want to do is you always want to split it into two different, equations, just like we did with the other, with the other ones. The only thing that changes is the sign and also the value right here. So, for example, if we have the absolute value of 3x plus 1 is less than or equal to 9, what we have to do is we have to split it into two different values. So we have this, or 3x plus 1 is greater than or equal to negative 9. This part right here never changes. Whatever's inside never changes. So that's the only thing that you want to keep in mind, is that this part right here never changes. So then we go ahead and we solve these two linear inequalities by so this first one by subtracting 1. We cross this out. We have 3x is less than or equal to 8. And then after that, what you want to do is you want to go ahead and divide by 3. And you have 8, or you have x is less than or equal to 8/3. And then this next one, you have 3x plus 1 is greater than or equal to negative 9. So then you get minus 1 on each side. And then you go ahead and you bring this down. You say 3x is greater than or equal to negative 10. And then you go ahead and you divide. And you put x is greater than or equal to negative 10/3. You always want to check afterwards. So number 1, split into two linear inequalities. inequalities to make sure to change the inequality sign, and also the the sign of the number whenever when so what I mean by this is basically you have to change. So you first have this is going to be one of the equations that you do. If you change it into a linear equation or into linear inequality, you have this. The thing that changes for the second one is the sign, which is this, or the and then the sign of the number. So which is this part. So you want to go ahead and change that in case, you know, whenever you put your second equation. That's what this means right here. You always want to change your sign. So then you have these two, and then you're going to go ahead and you're going to check after you're done. So you're going to check your solutions. So the first one, the first one you're going to check is 8/3. You're going to plug that in for x. So you're going to put 3 times 8/3, times 8/3 plus 1, is that less than or equal to 9? Okay, so you always want to check your solutions, because you want to check for extraneous solutions in case there's any. So this one comes out to be 8 plus 1 is less than or equal to 9. The absolute value of 8 plus 1 is less than or equal to 9. And then you want to go ahead and you want to solve this part. So you have the absolute value of 9 is less than or equal to 9, and 9 is less than or equal to 9. So because this is true, what this means is it has to be less than or equal to. So that is why it's a true statement. This next one we have check x equals -10/3. So you put 3, the absolute value of 3 times -10 over 3. Oh, let me move it more down. So you have the absolute value of 3 times negative 10 over 3 plus 1 is that greater than, or sorry, is that less than or equal to 9? And you always want to put your little question mark right there. So then you have the absolute value of, this crosses out, so negative 10 plus 1 is that less than or equal to 9. And then you go ahead and you put the absolute value of negative 9 is less than or equal to 9, and 9 is less than or equal to 9. So because this is also a true statement, your solutions are I believe they're going to be negative 10 thirds is less than or equal to x. Is less than or equal to 8 thirds. So basically those are your solutions. I'm not sure if it's actually, so let me see, hold on, because I'm not sure if it's actually that, because this is not the same as saying negative 10 thirds and 8 thirds, because basically, you know, it when you talk about that, it involves all the numbers. So if you graph it, I'm going to go ahead and try to graph it. The absolute value of 3x plus 1 is less than or equal to 9. So, and if we put anything, so negative 10 thirds, and then we have 8 thirds, oops, and then we have 8 thirds right here. So anything between negative 3.3 and 2.6, or I want to say 2.7 rather, but since it's repeating, so basically you would have this, and then give me a second, so where x equals, or sorry, where y equals 9. And if we say, I'm going to just try a number, so if I do negative 3, for example, if I check negative 3, we have 3 times negative 3 plus 1 is less than or equal to 9. So then we have negative 9 plus 1 is less than or equal to 9. Oops. And we have the absolute value -8 is less than or equal to 9, so then 8 is less than or equal to 9. So yes, these are certainly your solutions for, and you can also write them in interval notation. So you can say -10/3 to, oops, -10/3 to 8/3, if you want to write it like that. But yeah, I just wanted to make sure that this is actually also a true statement. So it's anything between these two numbers. So if we do another one,